Hi there. One of the coolest superpowers of our friendly neighborhood Spider-Man is the ability to climb up walls and stick to smooth surfaces like glass. And while this is considered a superpower for humans, sticking to glass is pretty easy for a lot of animals to do. But how do they do it? The animals we're going to talk about today are frogs and lizards. The two groups use two very different strategies to get the same result. We're not going to talk about bugs in this video because they use so many different adaptations spanning many different taxonomic groups to stick to glass. So let's stick to frogs and lizards. In order to stick to glass, frogs use wet adhesion. Wet adhesion is accomplished through the use of fluid to achieve maximum stickiness. A frog's toe pad is covered in hexagonal epidermal cells separated by relatively large grooves. Mucus glands introduce fluid into these intracellular channels, which keeps the toe pads wet. Frogs are then able to stick as a result of a combination of forces, including surface tension, friction, and viscosity between the toes and the substrate. In contrast, lizards use an entirely different sticky strategy. The majority of lizards that are able to stick to glass are found in the family Geckoda, with the notable exception of those from the group Anolis, otherwise known incorrectly as American chameleons. These lizards utilize a dry mechanical force, rather than wet adhesion like frogs. Gecko's toes are covered in tiny microscopic hairs called setae. When a gecko is walking on glass, these hairs find tiny imperfections in the surface and interact with them on an intermolecular scale using the van der Waals force. The foot of a tokay gecko contains about 500,000 of these structures. Each seta is 1/10 the diameter of a human hair and is between 30 and 130 nanometers long. Each seta also houses hundreds or even thousands of spatula-like structures between 0.2 and 0.5 nanometers long. The feet of a tokay gecko contain approximately 1 billion spatulae, giving them enough surface area for van der Waals force to become significant enough to stick to glass. Synthetic materials have been designed that mimic the sticking action of gecko feet, but they're still only experimental, so I wouldn't count on being able to fight crime in blue and red spandex anytime soon. Have any animal questions you want answered? Leave your questions in the comments below.
Created using Powtoon.